Hello guys, today we are going to learn about the VPC infrastructure. VPC stands for Virtual Private Cloud and how it is organized in the AWS, Amazon Web Services. Now your entire network could be moved as a virtual private network on the cloud. What you had to earlier do was buy some routers, switches, and then build up your network using wires or Wi-Fi. But now we could have all this on the cloud with just a few clicks of buttons. Now let's see how that is going to work. So let's talk about the Amazon console. So here is the Amazon console. We have options to log in as a root user or IAM user. We'll talk about this root user later on. But right now this is my account ID and I'm just going to log in using my account. And once I'm inside the account, you can have a look how this is working. Now, this is the console, and you have the options to look at various services like virtual machine or S3 buckets where you store data or databases, or where you can manage your users. Like I'm logged in as a user right now as the SID user. Now the root user, we'll talk about root users later on, but today's topic is VPC, Virtual Private Cloud. Now let's look at VPC. Now what's the VPC? It talks about regions and subnets and route tables, internet gateways, NAT gateways. So this is all VPC fundamentals, and we are going to talk about network ACLs and security groups. These are all the topics we are going to discuss today. So let's talk about VPC. If I click on region, region means places. And just like the name suggests, it has different places in the US and Africa and Asia. Oh, Hyderabad is coming up, but region is not opted in. So there are multiple regions I've opted in, and there are many regions I've not opted in. So Hyderabad is there and Mumbai, and I have a region in, I have a VPC in. So for every region, I have a default VPC that is created over here, and I've got total of 7 subnets. So what's happening here? This is my default VPC. Let's have a look at our default region. So this is my region where I have all my resources stored up. How is this working? Let's go inside. And voila, I've got one VPC and it says this is the default VPC. Fair enough. What happens? Do you get it by default? Yes, you do get it default. You get a default VPC in every region you have opted in. Now I've got this VPC. It is a name, so it is I've given a name. Now it is recommended that you create your own VPC. IPv4. If you have followed my lectures before, you know what IPv4 is. If you don't, this is IP addresses are a way to identify your resources on the cloud. So I'll just do a whiteboarding for you to show you how the resources are allocated addresses. It's just like why do you have an address at your home? Because you need to receive the mail. If you don't have an address, how are you going to receive the mail? Similarly, you have IP address. And here it is a range of IP addresses. It's called CID or classless interdomain routing. So we'll talk about IP addresses. It has got a route table associated and a network ACL. This is and it is, you can create a VPC if you want. Create a VPC. And how does this work? Well, you could do the just a VPC or you could create multiple things at the same time. Let's look at the multiple things. So I could give it a name. Let's give it a name, project. Project 007. Okay, 007, that's better. So I've got the James Bond project over here. And now what is the IP? So with slash 16, I can get 65,536 addresses. How does that work? Well, we could look at this website over here, an IP address guide. And this one shows you if I have this IP with the range. So IP address is 32 bits in total. And if I have this range, what do I get? I get 256 IP addresses. Voila. This is slash 24, means 24 bits you cannot change. Only the last bit. So this is 8 bits, 8 bits, and 8 bits. So slash 24 means this is the network part and you cannot change. So you're left with just the 8 bits. You can change this last 8 bits, and that is why the 255, the subnet mask, represents the parts you cannot change, 255, and represents the parts which you can change. So these numbers tell you which parts are available for you as the host part. The first IP is going to be this, and this is going to be the last IP. But just remember, you cannot use the first IP and you cannot use the last IP. And there are 3 more IPs that you cannot use in Amazon VPC. So we'll talk about this. So it comes down in a normal network, it comes down to 254. In Amazon VPC, it comes down to 251 because you cannot use total of 5 IPs. So that would be 251. And does that make sense over here? Okay, let's look at the project. So VPC is there and I'm creating subnet. So I could have a subnet in US East 1. So this is a availability zone. So this is the region. And hold on a second. Is that uh, availability zone? Yes, it is one region, and I'm putting it into 2. So availability zones are naturally separated, normally separated by 100 kilometers of distance. So if this one fails, I do have this one available, and each one is mapped to a route table. So I have route tables over here. Now remember, every VPC, so VPC can span availability zones, but it cannot span a region. It cannot go beyond a region. So my VPC is spanning 2 availability zones. Both of them are there, and they're attached to, they have a public route table, and public route table, if you look closely, it is mapping out to IGW. So I'll try to explain you it in a picture as well. And these are the private route tables, and they are mapping out to a VPC endpoint. Let's look at this. We had that last 16, I'm going to get 65,000, but what happens if I say I want just slash 24, 256 IPs? Fair enough. And tenancy, we are going to talk about tenancy. How many availability zones? Let's say I want to span 3 availability zones. Fair enough. So now I've got 3 availability zones. And if 2 goes down, another one is active. Some natural disaster occurs. How many subnets I want? Public subnets. Each one is going to have one public subnet, and each one is going to have one private subnet. Well, I could say 6 private subnets. There are not 6 private subnets are there, and they are attached to what? They are attached to and do I want a NAT gateway? I can put a NAT gateway, and this is going to cost you money. So be careful when you're creating NAT gateways. We'll talk about NAT in a while, but if I want, I can put 1 per AZ, and if I put 1 per AZ, see, the route table is mapping. So the private route table over here is mapping to NAT public 1. Over here, private 2 is mapping to, in the second availability zone, you can see the link, and it is mapping to NAT public 2. And the third one is mapping to NAT, sorry, this one is mapping to NAT public 3. So that is mapping to the availability zone. For each availability zone, I'm getting a 1 NAT gateway. Well, I don't want NAT gateways right now because I don't want to spend money over here. So let's say none. And that's it. Can I say, do I want VPC endpoints? Well, I could have a VPC endpoint, and we'll talk about endpoints later on, but there's a way to not go out to the internet and just connect to your services directly. So I don't want a VPC endpoint. Let's say create VPC. So I'm creating VPC, associating route tables, creating subnets. Everything is being done over here. And let's look at, wow, that is cool. A lot of things is happening automatically instead of creating. And once I'm done, I can click on View VPC and let's have a look. So my VPC is created, Project James Bond, and I've got this subnet created as well. So let's look at the subnet. Oh, so my this one was the original subnet associated with VPC I had created earlier. This is associated with the default VPC. And what about the subnet I have now? Let's say I don't want the default VPC. I'm just talking about the James Bond. So project just one. And what is the subnet I have in this? Ooh, it doesn't show anything. So let's click on refresh. And once I click on refresh, you can see all the subnets that have been created in different availability zones over here. And they're going /28. So each one is having just 11 IP addresses. Why am I having slash in every? Because it has been partitions. I told you that, we are creating three subnets and one in each availability zone, and therefore it has been subnetted. So each subnet is having /28. /28 means actually, let's look at this /28. What does it mean? /24 meant 251 IPs available total. What does /28 mean? And /28 means I have around 16 IPs, but it shows 11. Why? Because 5 IPs are reserved. So 5 IPs are reserved, and I'm having it in every. And I can assign basically 11 devices, resources, databases, whatever I have. They can have the IP addresses in the range of 10. This is a private IP, guys. And it is attached to an internet gateway. What is my internet gateway? Well, I just have one internet gateway for project IGW, and it is attached over here. But if I already had one internet gateway earlier, and that was the default one was attached to this internet gateway, and this is attached to the default VPC. So every VPC is going to be attached to an internet gateway. Let's look at a map over here, and this will make much more sense. Okay, fail, fail, turn off, and let me insert a sticker. I want to insert a sticker, and this is my sticker going to be in VPC with public and private subnets. Okay, so this one is over here, and this one shows you, and this one is in the range of 172.31. If we look at this, let's make it. So we got this VPC with 65,000 addresses, and it has been divided into 4 parts into different availability zones, and each one has 4,091 addresses. Well, it says 96. Why? Because 5 addresses are used up. I'll just talk about them as well. And where is the internet gateway into all this? So let me just put in a sticker again. The sticker, and where do I have the internet gateway? Presently. Okay, so I've got this internet gateway over here. And what is the job of the internet gateway? The job of the internet gateway is to take out traffic. So I'm going to have traffic going from public subnet to the internet gateway and out to the world. Why? This is very thick, so I don't want that thick. And maybe let's choose a different color. So it's going out to the internet, and So without the internet gateway, you cannot reach out to the internet. But what about the private subnet? If you know about NAT, what is NAT? Network address translation. So let's put some resources into this. Okay, let's put some resources quickly. And I want to put a database. So I want a database, let's say Aurora database, and I want this into my private subnet. I don't want anybody just accessing out my devices. So I've got this one. Let's and I want a high availability. So if this one goes down, I want this one up and active. So I've got two databases and they are in private subnet and they've got the IP over in this range. Now let's see the IP. No. Okay, so let's put the IP. Let me get the IP. So this one is going to be, oh, that's 48. I want it to go to 22. No, even less, 14. 14 is too much. Let's make it 10. 172.31.32 dot. Well, remember 0, 1, 2, 3, you cannot use. So I'll start with 4. And where is this IP going to be? Over here? Text. This one can have another IP. Let's say 3D text. That's good. I don't know. Let's make it 10 again. 172.31.48.4. Well, these are two different subnets. That is why we use subnets. See, they are not the same IP. Why they're not the same? Oh, what did happen there? What did go wrong there? So let me put the text again. 172.31.48.4. Okay. So it keeps disappearing all the time. This is the last time I'm going to try. Always give 3 chances. 48.4. That's it. I've got this. 3D text. So I can move this a bit if I want. But let's leave it like that. Okay. Do you want to put a color? We could put a color on this. Fair enough. Okay. So I've got two subnets. So you can see that this IP address is different for this from this. Why? Because these are two different. This is 32.4. This is 48.4. That is why we need to create subnets. And this IP, if I add another resource into this, sticker. Yeah. So I had another IP into this. Let's say another database, a RDS database. And this one was there. What we could do is assign IP addresses over here. So I could give this the IP of the same 31.48.4, but this time over here I could have .5 and .6 and .7 depending upon all the resources I have. So this one is .5 and let's put it over here. So this one is going to be .5. So rest of these three parts are going to be the same. So this is the concept of subnets. We could have different subnets. And this 48.4 is different from this 32.4. Over here, let's put some resources in the public subnet. A public subnet is cool. So let's see here. Okay. Let's go to what do I want? I want to put some compute virtual machines. Let's put some virtual machines. So this is a virtual machine. Virtual machine is just like a normal Windows, but you run it on the cloud. So you don't buy any computers. And I'm going to have multiple of them. And into this subnet. Oh, I've got multiple VPCs, and I could have 4091 of them. They could have these addresses or some other resources as well. So let's put them here. Fair enough. And I could give them IP addresses. Let's give them IP addresses quickly. Okay, just a normal text. We'll do 172.31.16. Dot starting with 4. Okay, and this one. Let's go here. Let's go here. Okay, so this one is going to have dot 5 and this one could have dot 6, and you can see how it is going, right? But it is all going to be dot 16 because this is the subnet with dot 16. Here it is going to start with 0.1 and all that. So this is the concept of an IP addresses can uniquely identify. So this one is the resource going to this EC2, and this one is going to, so these three parts are going to be same, but this last part is going to identify the resource in the subnet over here, internet gateway. But what happens if these databases want to communicate to the internet? What happens then? Well, if this wants to communicate with the internet, it cannot go directly over here. It has to go to through something called a NAT gateway. So let me put a NAT gateway in the private public subnet. We could have a NAT gateway in private subnet, but that is a topic coming up later on. Over here, let's go into private subnet. Let's add some stickers. Add a sticker, and I want a NAT gateway. So there's my NAT gateway. Networking, and here's my NAT gateway. Let's put the NAT gateway. Okay, so my NAT gateway is going to have a public IP. Public IPs are IPs that are routable on the internet. So these are all private IPs, and anything you see in the range of 10, 172.31.0 to, oh, well, I'll talk about the private IPs. It is from 172.31. Can't remember the last range. It's actually 0 to 16 or something. Let me just check on that. And the last one is 192.168. So anything starting with 192.168, that is why you see that in the home. So this is the NAT gateway, and I've put that into the public subnet. So let me just put it here somewhere. Yeah. So it is going to be a public subnet over here. And if they want to communicate, they have to go to the NAT gateway, and NAT gateway will translate that traffic from, so what it will do, it will convert the traffic and make it, let's use the green color pen. So from here, it will go, and this traffic can flow over to the internet. So this is all good. And this is the job of NAT gateway. It will translate this traffic. Let's say it is coming from 172.31.48.5, and it will translate it into public IP. So let's say if the public IP is 51.1.1. So the internet, the public IP is working on the internet. Private IPs, remember, private IPs never work. But the job of the NAT gateway is to translate traffic coming from private subnets and private IPs into public. And remember, anything initiating, you cannot initiate traffic directly from outside. to the private subnet. If it is a response for the traffic going out from here, well, that is a route. So this is all about internet gateway. Internet gateway, the job is to route traffic from here to, and public subnets they do not require because they already have a public. These resources are going to have a public IP, so they can take the traffic out. But private subnets, yeah. And how do you know what is a private subnet and what is a public subnet? Well, you have this route, and I'm going to show you in the this route is in the public, and it is pointing out to where? To IGW, Internet Gateway. This route is available in the public subnet, but it is not there in the private subnet. That is why the public subnet, and this is the route to the internet, the whole internet. So this route is there in the route table. What are route tables? We just saw the route table over here. We go back here. So these are the route tables. And this is the route table. And which one is the public one? Well, let's look at the public. This is a private route table. And if you look at this route table, it has only one route, routing to our network that we created, 10.0.0.0. But it is not routing to the whole internet. But if I go into the public subnet, let's look at the public subnet over here. This one was created earlier. This one is the default one, and it has the route. So this one is for my default VPC, and you can see this route table is pointing to the internet gateway. So this is IGW, internet gateway. Any traffic going out to the internet will go to there, and that is why it is a public subnet, and rest of them are private because they don't have this route. What is the route table? The route table is like a GPS. So remember, when you go into your car, you pull out your phone, type in a location, and the Google Maps or Apple Maps, whatever service you use, give you multiple routes. Here, the same thing. All my EC2, the virtual machines, are going to pull out this route table and say, well, I want to go to this local traffic. Well, you can go locally. I want to go out to the world, 51.1.1. Go out to the internet gateway. Fair enough. But if you only have a route table that is private, well, you cannot go out to the internet because you don't have that route. You do not know. So Google Maps is going to say, well, I cannot find the destination. Here, you don't have the route, so you cannot. So you must have a public route table to reach out to the internet. Okay, let's look at the map again over here. So this is public subnet, private subnet, VPC. VPC spans multiple availability zones, but it is inside a region. So this is inside a region, and this is going out to the internet gateway. Okay, fair enough. Now, how do we control the traffic? So here we have the NAT gateways. I don't have any NAT gateways because it's going to cost money and I'm not creating any. Elastic IPs, I could have public IPs. I could have 5 of them per region. Now I could create an elastic IP and allocate an elastic IP. So do I want to allocate from Amazon Pools IP address? Yes, I could. Allocate to who? Allocate to who? Network product group. So I could do that and allocate an IP. So I don't want to do that right now. And if I could put an elastic IP to this one. And let's look at our resources over here. So I've got a EC2. Let's go here. I've got my public IPs and private IPs over here. So public IP and private IP. I've got let's look at the networking part. The networking part, it is attached to a VPC. So it is inside a VPC. Also, it is inside a subnet. So it is inside a public subnet. And does it have a elastic network interface? Yes, it does. It has a public IP and I could give it another public IP if I want. I could allocate a public IP to this. So that would be the elastic IP. Elastic IP is, let's say this EC2 goes down. What happens? My IP is there and it is fixed. I could take it out from here and just put it into another EC2. So that would be, just you looked at the allocate thing. ENI is an internet network interface. Let's look at this. And this one is there and it has a public IP. And can I detach? So if I create a ENI, I could detach it from there. So here is, look at this. Where did it go? Okay, it is in the networking part. I have to go back to VPCs. So we talked about the route tables, we talked about internet gateways, we talked about NAT gateways routing traffic from private to public. So it converts the private IP into public and does NAT translations. Let's talk about this elastic IPs. So elastic IPs are here. Let's say there was a EC2 resource and it does not have a public IP. What I could do is create a elastic IP, create a elastic IP, and then give it out to, I could associate it over there. Now let's talk about elastic network interface. Remember the network cards we used to have? I could create a network card, but this is time it's going to be virtual. So where is that elastic network interface? ENI. I could create an ENI if I could only find it. So endpoints and gateways, route tables, elastic IPs. If I could only find an ENI. Elastic IPs network interfaces. So it's inside the network interfaces. And I could create a network interface and I could get a private IP. Also, I could get a public IP. So if I want, I could get a public IP over here. First, I have to select the subnet. So if I select the public subnet, so let's say there was a resource in our project 007 over here, and I would do that, and then I would attach the public IP, I would attach a security group, and then I could put this elastic. It's just like plugging out a network interface card and plug it into a machine, and whatever IP and MAC that interface card has will be attached there over there. Like here, I already have one this network interface over here, and it is attached, and it has what? What does it have? It has a private IP and a public IP. If I could just detach it and put it into another machine, that machine would have the same IP and the same public IP. So this is about elastic network interfaces. Okay, my meeting is going to end, and I'm going to finish this into 5 minutes. Let's see. Security groups. How do I Security groups are inside, eh, there are like a firewall around resources. So I've got a security group created over here. Let's go here. What does this security? They do only allow rules. So if anything is allowed, the return traffic would be allowed. So over here, what does it allow? It allows port 80, that is HTTP, all web traffic is allowed. From where? From everywhere. 443 is allowed. And SSH, that is for me to connect to my, so it is allowed from anywhere. So for SSH, it is secure and I have a key and you don't. So you cannot connect to my EC2 instances. Over here, outbound rules. Now let's say it says allow all traffic. So by default, all traffic is allowed outbound if it is originating from here. But if let's say if I had a rule here that says deny all HTTP traffic, well, whatever originated from, if it is originating from inside, say inbound rules, it had the allow rule. Let's say if there was a deny rule in the inbound rules, what would happen? Because the traffic initiated from internally, a reply for that HTTP would be denied. But any web server who tries to connect directly would be denied. Why? Because instead of allow for HTTP, what would I have? I would have deny. Lastly, network ACLs. Let's talk about network ACLs quickly. Oh, knackle. They're just like, ACL, but what you have is, okay, I'm again back into EC2 mode. I shouldn't be here. I should be in VPC. Once I'm in VPC, I could go to my network ACL. Let's have a look at network ACL. And I have a network ACL that was attached with the default VPC. And this ACL is not at a resource level. Remember, security groups are around the EC2. So every EC2 instance is connected with a security group, but this one is connected. And what does this say? It is a top-down approach. So the first rule would be process first. So it says allow all ICMP ping traffic. No, it says deny traffic ICMP traffic from this IP, and it says denied. Let's say I had a rule saying 101 and it says allow all ICMP traffic from 9.9, the same IP. Who would we believe? Well, we would believe the first rule. So if you have a rule, it is called a top-down approach. That is why you should put in some numbers so that you later on, if you want to modify this, you have some space. So this is rule number 100. And let's say I want to put in rule number 101 and say allow all ICMP, but from 9.9.1. So this traffic from this would be denied, but 9.9.1 would be allowed. Because here I'm just specifying one IP. 110 says allow all traffic from where? From everywhere, all traffic is allowed. So you can see, even though this rule says allow all traffic, because this rule came in first, all traffic from this IP would be denied, but any other traffic would be allowed. So I'm allowing all traffic. Why? Because I'm allowing 3 traffics on my security group level. So all traffic is allowed through my network ACL except 9.9.9, and at the security group level, I'm only allowing HTTP, HTTPS, and SSH traffic, and that is all secure. Outbound rule. Well, I want to allow all traffic, and I'm not, if all traffic has been allowed outside. That's the end of the session for VPC, guys. So this is how you create your VPC. This is you attach your network ACL at the subnet level over here. So EC2 ACL, network ACL is attached here, and security group is attached at the EC2 instance. So this could be our security group, and this will, let's say I